Hi all. Welcome to this video and today we are going to learn about a very important section in memory management and that is loading, linking and address mapping. Okay. So now you might be hearing of these terms most probably in compilers or in memory management section. So in this tutorial, in this video, we are going to learn about what does this term mean, and in terms of operating system, how does these term affect the memory management. Okay, so let's begin with loading. So loading means definitely to load the stuffs. Now what we are loading here, so we are bringing for in terms of operating system when processes are running. So what happens that if we want that we need to bring the entire program, so our program are being stored in the secondary memory. Okay, so we have our program stored in secondary memory and our processes are running in the main memory from the main memory. So what does the operating system does, like if we want, so here is our program residing. So if we want entire, if we are shifting the entire program code into the main memory while execution. Okay, so in this way what we are doing that we are not pulling up the pieces of program from the secondary memory to main memory, but we are doing the bulk loading of the entire program from the secondary memory to the main memory. That is bringing the program from the secondary memory to the main memory is called the loading. Now loading could be different, could be having different types, but right now when we talk of loading, it means about bringing the program from secondary memory to main memory. Okay, now right now I just talked about we are trying to bring the entire program, or we are trying to bring the pieces or chunks of program from secondary memory to main memory. So the loading could be of different types. First type of loading is called static loading. Okay, and the second type of loading is called dynamic loading. So these are the two types of loading. So static loading means loading the entire program at once before the start of the program execution. That is called the static loading. Okay, so what does the OS does is, in this case of static loading, what will it do? It will load the entire program whenever the program execution starts. Before that, it will load the entire program, whatever the program is required for execution, it will load entirely into the main memory. So this is called loading program entirely from secondary memory to main memory before the execution of the program, or before program execution we are loading the entire program from secondary memory to main memory. That is, it does the bulk load. So whatever is required, it loads at once before the execution. It's just like you are trying to prepare a recipe, you are trying to prepare a dish, and whatever things are being required for preparation, you are just pulling all at once on the table, so that you can have all these stuffs together in one place, right? So this is called the static loading, that is loading entire program into memory before the start of program execution. Now what does it uh, there are some advantages and advantages. So first thing is program execution will be faster. That is an advantage, right? Because since you have everything at your hand, so program execution will be faster. Okay, you won't need to wait for bringing back something which is not there and all. Okay, and also if static we will be talking about linking as well. So if static loading is used, definitely with static loading we need to have the static linking. Okay, so we will be talking about this term later. First, let's talk about loading. So program execution will be faster in case of static loading, but there is one disadvantage to this kind of loading. And what is this disadvantage? That there won't be a proper memory utilization, because what is, whether it is required or not, you are bringing everything at once. Okay, so it will lead to an inefficient utilization of memory. Inefficient utilization of memory. Why it is inefficient utilization of memory? Because for this time, if something is required or not required, like whether it is required or not required, not required, you are bringing everything at once. Okay, you are bringing everything at one place, whether it is required or not. So in this way, it leads to inefficient utilization of memory. Okay, the entire program is being brought, but at some stage we are running only a section of program. We don't require the entire program, however we have brought in the entire program from the secondary memory to the main memory. So this is one disadvantage, but it will lead to program execution faster. So in case our program is smaller, we can bring the entire program into the main memory before program execution. But if the program is longer, or it constitutes of huge space, then it is not suggestible to bring the entire program into the main memory. With static loading comes the static linking as well, right? Now let's talk about the dynamic loading. So in case of this dynamic loading, we are not loading the entire program on once. So dynamic loading means loading the program on demand. Okay, on demand we are loading the program into the main memory. So loading the program on demand is called dynamic loading, right? So what does this on demand means? When we are required the program into the main memory, then only we are loading. Like we are loading in chunks or sections, like we are loading some part whenever it is required. Now with the execution flow, if we require some more sections, we are then again reloading it like this way. Okay, in chunks we are loading. So we are loading program on demand. So it leads to definitely efficient utilization of memory. Okay, which is the shortcoming of the previous one. Okay, so it leads to efficient utilization. And obviously, since we are loading chunks in chunks, then definitely program execution will be slower, in contrast with the static loading. So program execution is slower definitely. Now as we talked about, static loading comes with static linking, so dynamic loading comes with dynamic linking as well. Okay, so this dynamic linking. Now since we have already talked about loading, let's talk about linking. What does linking means? So I hope you're clear with the loading part. So linking means, let's say we have a program. Let's say we have program like C program, and here we have this int x and x equal to add something, some part, and then so on the flow. And then we have this add module written up somewhere, like adding for to function and something like that. Again we have some module called subtract, and let's say it's not in the same program, it's written somewhere. So it is written in some other module like that, and here is this function. So we, since we are using this function in the main program, so when we are executing this part, so we need to link up this ties, so that these function call could happen while execution of this program, right? So this way we are linking different modules of the program together, that is called the linking part, right? So linking actually means establishing the relation between different modules. Like this is a small function, but there could be some bigger modules stored somewhere else. So linking means establishing the ties, or you can say the broken links between the different modules that is being required for program execution. Okay, so establishing the linking between all the modules or functions of the program. Okay, so this is called linking. Now, as we have already talked about, that linking could be of two types: dynamic linking and static linking. So when we are using the static loading, definitely it comes with static linking, and when we are using the static dynamic loading, it comes with dynamic linking as well. So this is all about linking and loading. We'll talk about the next as the address binding, which is a very important part for memory management in the upcoming video. So, yeah, please keep watching, and thanks for watching this video. So, thank you very much. Bye bye.